All right, so let's finish off game 3.3, questions numbers 17, 18, and 19. Number 17 says, if there are research models on exactly two floors, which one of the following statements can be false? Okay, can be false, which means not necessarily true. If you wanted to put it in terms of true, that would be not necessarily true. Okay, so let's see which one of these can be false or are not necessarily true. But the first thing we need to do is to figure out what we can deduce from the information that they gave us for this question. The information they gave us was that there are research models on exactly two floors. Can we place those two research models? Do we know where they're going to go? Yes, right? Because we already figured out that this was a production model. So if there are going to be two research, then they're going to have to go here and here. Okay, so we put those guys in there, and now before we look further at the answer choices, we want to see if there's any other analysis we can do. And we do have some rules about research models. In fact, we have two rules about research models that should be very helpful to us here. First, we know that any research model is going to have to be new because it cannot be used. That comes from this rule, right? So we put the new here, and that takes care of applying this rule. But now we need to look at this rule, right? It says that wherever you have a research model, you cannot have a sports car. So we know that these are not going to be sports cars, they're going to be family cars. I think that that's pretty straightforward, and most of you should not have an issue with that. So now let's see if we can answer the question. Which one of the following statements can be false? A says there are family cars on floor 1. That has to be true. So therefore, it cannot be false. It must be true. Okay? So I should have said, actually, when they say which one of the following statements can be false, the other way of saying that is they're not necessarily true, and the wrong answers, this is what I should have said that I did not say, the wrong answers, okay, are things that must be true. All right? If they ask you what can be false, and they give you 5 choices, that means there's going to be 4 wrong answers, which have the quality of must be true. Okay? So A, for example, must be true. We know that there are going to be family cars on floor 1. So let's go to B. There are research models on floor 1. Yes, that must be true. So that's not the answer either, because the wrong answers are must be true. So C says there are new cars on floor 2. That must be true, right? We figured that out already. So D says there are research models on floor 2. That also must be true. So A, B, C, and D are all wrong answers because they must be true. And in this case, we're looking for the thing that is not necessarily true, or in other words, the thing that can be false. So hopefully E can be false. E says there are family cars on floor 3. And you notice that that's the one spot that we were not able to fill in, right? So that's why they went there, for the thing that does not have to be true or could be false, because that's the thing that we don't know about. So it makes sense that that would be our answer, or that's where our answer would come from. And so E is the right answer here, because we don't know whether 3 is going to be a family car or a sports car. Okay, let's look at number 18. Number 18 says, if all the new cars in the exhibition are research models, which one of the following statements must be true? So wherever we put a new car, we have to put a research model. Okay, so wherever we see an N, for example, and this is just an example, right, but it does allow us to fill in part of our diagram. If we put an N here, then we have to put an R here. And if we put an R here, because of this rule that says there are no research sports cars, right, if we put an R here, then we have to put an F here. All right, so the bottom line, though, the generalization that we can reach is that if we put an N, then we have to put an R, and if we put an R, we have to put an F. So wherever we put an N, we have to put an F, okay? Now, I don't know if there's anything else that we're able to learn from this, or actually fill, any other spaces that we're able to actually fill into our diagram, because we don't know for sure whether floor 2 is going to have a new car in it. So we can't just guess. We could say that if we do put a new car here, then we know that this is going to be research and this is going to be family. But since we don't know that we're going to put a new car on floor 2, we don't want to jump the gun on that. And as far as the other as far as this floor, we're not going to be able to fill in this spot because we don't know that there's no new car here. So this is a used car. So the extra information that they're giving us doesn't really apply to floor 3. Okay? So we did what we could in terms of filling it in. So let's see if we can find the answer now, because they're saying something must be true. All right, so we would go through there, and maybe you have an intuition about what must be true. And we'll talk about that in a second, but I'd like to, for the people, maybe you don't have an intuition and you might just have to go through the answer choices. That's a perfectly fine way to do this question. It might not be as fast as if you use the intuition directly, but I want to make sure that people know that even if you don't have an aha moment where you figure out something that must be true, you can still go to the answer choices and go through them one by one and see whether the answer choices must be true or not. And then you can still find the answer that way. And the mindset when you're doing process of elimination, this is actually important. A lot of students have the wrong mindset when they're trying to do process of elimination on must be true. The mindset should be, let me see, when you come across an answer choice, you should try to make it not true. Okay? You should try to basically say F you to the must be true question, to the must be true answer. So we go to A, and we want to try to avoid doing what they say in A. So for example, they say all the family cars in the exhibition are new. So could we have a family car that was not new? So let's see. Could we put a family car here, for example, right? And the answer is yeah, that can be a family car. The information they just gave us stems from, or starts with, a car being new, which leads it to research, which leads it to family. But the flow does not go the other way around. Just because something is a family car does not mean that it has to be new, and we can show that by putting an F right here. So we successfully avoided doing what they said we had to do in answer choice A, which means answer choice A is not right. Okay? And that's the mindset you need to use on all process of elimination when you're doing it within a must be true question. Okay, so let's look at B and do the same thing. All the family cars in the exhibition are research models. Can we have a family car without it being research? And again, the same example that we came up with last time proves, so maybe we should leave this example up on the board for a second. This, again, proves that just because you're a family car does not mean that you need to be a research model. You can be production. And if you think for a second about what they're trying to do to you with answer choices A and B, they're trying to get you to go the wrong way on a conditional rule, right? We have a conditional rule that says, like, if you're an N, then you have to be an R, and if you're an R, then you have to be an F. And on answer choice A, what they try to get us to do is say, okay, well, since N leads to R and R leads to F, they're trying to confuse you and get you to say that F leads to N. They're trying to get you to go the wrong way on a conditional rule. And that's the same thing they're doing in answer choice B. They're trying to get you to go from F to R. What we know is that if we end up with a research model, then it has to be a family car. But that does not mean that all family cars have to be research models, okay? That's the thing that we're really used to dealing with, or really used to avoiding, which is going the wrong way on a conditional arrow. So A and B are out. And if we wanted to prove it, we'd prove it right here by putting F on floor 3, and that shows us that we can have an F without having a research model, and we can have an F without having a new car, okay? So let's get rid of this now. All the family cars in the exhibition are used. No, we know that that's definitely not true, because they had told us from the beginning of the game that floor 1 would have a new car on it. Okay, and now when we apply the information that they gave us in number 18, we know that if it's new, then it had to be research, and then that if it's research, it had to be family. So in answer choice C, they're saying all the family cars in the exhibition are used. That's not true either. It's very possible if we look at floor 1 that we can have a family car that's new, right? So C cannot be right. All the production models in the exhibition are family cars. So what they're saying is if you have a production model, then you would have to be a family car. So let's look at answer choice D. It says all the new cars in the exhibition are family cars. And that looks like it might be the right answer, because we said earlier that we have this conditional rule, right? I'll write it down here. We basically have this conditional rule that says if you're a new car, then we know you're a research model, and this is what they gave us for the prompt in number 18. And then we also knew that if you're a research model, you cannot be a used car, which means you have to be a family car. So if you're a new car, you have to be a family car. That's the rule we've been using as we've been getting rid of A, B, and C. But now we look at D, and it says all new cars in the exhibition are family cars. And if we look at this rule that we came up with, yeah, that definitely has to be true. So D would be the answer here. Okay. And then if we look at E, just to make sure, we would get rid of E because it says all the production models in the exhibition are family cars. And we just showed that that does not have to be true because, for example, on floor 3, we can put in a sports car and it works just fine. So you can have a production car without it being a family car. All right. So let's quickly look at number 19. 1 second. Okay. Number 19. And number 19 says, if all the production models in the exhibition are used, which one of the following statements must be true? All the production models are used. So this rule is basically saying if you're production, then you're used, because it's saying all the production are used. So if you're production, then you have to be used. And they want to say which one of the following must be true. So basically we're saying wherever we put a P here, it would have to be used. So for example, what's the contrapositive of this? Okay, that means if you're not used, then you're not production, right? And what is it? So we just took the contrapositive, okay? And what does it mean to be not used? In this game, there's only two choices. Either you're used or you're new. So if you're not used, then you're new. So we would say if you're new, and what does it mean to not be production? Well, if you're not production, then you have to be research. So we would say if you're not used, which means you're new, then you have to be research, okay? Because not production means research. So the first thing we do is take the contrapositive, and then we just translated the contrapositive. And the reason we're able to do that translation is because there's only two choices for each category. So if you're not used, you have to be new. So we just translate that. And if you're not production, you're research. So we just translated that, okay? So now we basically, we have two versions of the rule. We have this first version which says if you're P, then you're U. And then we have the second version which says if you're N, then you're R. Okay? So wherever we see an N, we can put an R down. That's here, right? And then we know that if you're research, you have to be family because of this rule, which says if you're research, you can't be a sports car. So if you're research, you have to be family. So we can put an F down, right? And can we do anything further? It doesn't look like it because on floor 2, right, we don't know whether floor 2 is used or new, and we don't know whether it's production. So we can't really set this rule off, okay? So let's see if we can figure out what must be true then. If we, because we did figure this and this out. So these could very well show up on the answer, and that's really what we're hoping for. Something that we figured out. We figured out that this has to be true, so we're hoping that that'll show up in the answer choices. Most of the time, that's what happened. That's what happens. Let's look at number 19 then, the answer choices. It says there are family cars on floor 1. There you go. This is what we were looking for, right? This is something that we figured out must be true, and they gave it to us in answer choice A, so answer choice A is going to be right. And I'm running out of time. I would encourage you to go through B, C, D, and E and look at why they don't have to be true. And again, as a reminder, just like we did on number 18, when you're getting rid of B, C, D, and E, what you would want to do is to prove that they do not have to be true by coming up with an example, okay? By coming up with an example by saying, no, B does not have to be true because I could do X, Y, Z, all right? So that's it for this game. And let me just say really quickly that some people have trouble with the setup on this game because they think that maybe it doesn't fit into one of the standard categories of either trying to put things in order or trying to put things in group. And to some extent, that's in groups. And to some extent, that's true. Because here, you can think of the floors as groups, 1, 2, and 3. And I said this at the beginning, but I just want to emphasize it. You can think of the floors as groups. So we have a group 1, we have group 2, we have group 3. But we don't just have one set of variables and we need to figure out which one of them goes in which group, okay? We have specific choices to make. We have 3 discrete choices to make. We have to choose for each group between an N and a U, a P and an R, and an F and an S. So that's what's kind of different about this game. But if you really, beyond that, that's kind of a superficial difference. We need to make groups, and we need to choose 3 for each group, and we have a specific way that we're going to make that choice. But this game, you can really call it a grouping game, and I don't think you're stretching the idea very, very much. So that's how I would classify this game. And the reason I'm saying that is because a lot of students were asking, what kind of game is this, and they let that kind of threw them off on the game. And the answer to that question is this is a grouping game where you're just making choices for each group between these discrete options, N versus U, P versus R, and F versus S. Okay, I've said that enough times now, so I'm going to stop the video and I will see you in the next one.